right, guys, so we are now starting chapter 3. So we're going to get into the heart of geometry now. So let's go ahead and take a look at what we have going on. So we're doing 3.1 and 3.2 together because they're pretty much the conditional and the converse of two chapters. So this is parallel lines and transversals, okay? So the first thing we're going to look at is, first of all, if you have a set of parallel lines. So remember, parallel lines are lines that never intersect, okay? You will see that they're parallel because they'll have some random arrow. It won't be at the end, okay? Obviously, if they're at the end, that means they're lines. But if you have some random arrows, like just floating around on the line, that means those two lines are parallel. So that is the symbol for your eyes to know that this line and this line, so we'll call this line A, and we'll call this line B. So lines A and B are parallel. So now, what about a line that cuts across two or more parallel lines? So if I were to take a line and cut across like this, I'm going to call this line T. Okay, this line is known as the transversal. Okay, so this line is known as the transversal. And with this line that is a transversal, there are lots of special properties and relationships between angles that are going to start happening. Okay, and this is a good reason why geometry works the way that it does. So you've got two parallel lines, or you may have 5 parallel lines, you may have 6. It doesn't matter. You have a bunch of parallel lines. A line that cuts across is going to be called your transversal. All right, so let's talk about these relationships. So here are some angles that are formed. So the first angle, if you'll notice, I have stars here. So this star and this star. So let's identify. So this line right here is our transversal, and we'll call these lines A and B just to be consistent. So anytime you're looking at the relationship between the two angles, always look for the transversal. Okay, so once you have your transversal identified, you notice that the stars are both touching the same transversal. This star is touching line A, this star is touching line B. But just notice they're just on opposite sides of the transversal. So think about it as this is if you box this up, okay, so let's say this is a neighborhood right here in this little box. You live on one side of the street, your friend lives over here on this side of the street. When you see this relationship, this is called alternate interior angles. Alternate meaning they're on alternate sides of the transversal. Interior meaning they're inside the neighborhood, okay? So if you live on this street right here, your friend is up here on this street, the bus picks you up here, the bus picks them up here, okay? And the cool thing about these two angles is they will always be congruent to each other. They'll always be equal. So part equals part. All right, now look over here. It's very similar, okay? So let's identify that transversal. So there's the transversal. Here's line A, here's line B again. So I'm going to identify that transversal. And now I notice that my stars are still on alternating sides, but this time, if you think about it, they're outside of that neighborhood. So when that happens, they are called alternate exterior. So if they're inside, they're going to be interior. If they're outside, they're going to be exterior. And these are also always going to be congruent. And I will move these this way. So those are your first two relationships between parallel lines and a transversal. All right. So two more relationships. Now, if you'll notice, let's identify that transversal. And I'm going to color code it here, transversal. We have line A and we have line B. Now notice they're on the same side of the transversal. So now they're on the same side of the street. But now look. This guy is inside the neighborhood. This guy's outside the neighborhood. But if you think about it like this, I've always thought if you were to draw a circle like a pie, and you draw a circle here, notice how this star is in the same corner as this star. So let me make my circles a little bit better so you can kind of get a better idea of what I'm talking about. If you were to draw a circle, a significant one that you can make sense of, notice how this is in the upper left corner of the circle and this is in the upper left corner of the circle. Anytime they're in the same part of the circle, those are called corresponding angles. Those are called corresponding angles, and they too are congruent. Okay, so anytime, so when you're looking at that transversal, and if you draw that circle, if you're unsure, if you're not sure if it's alternate interior, alternate exterior, always look, are they on the same side of the transversal? If they're on the same side of the transversal, well, then they're probably going to be corresponding if one is in and one is out. Okay, so just draw that circle and look. Are they in the same part? Are they the same slice of pie? They're both in the upper left corner. Upper left. Okay? All right, let's look at this other relationship. Now this time, so here's our transversal. And if I look at the transversal, I see these two are on the same side, but this time they're both inside. So when they are on the same side and they're both inside, these are what we call consecutive or same side interior angles, because they're on the same side and they're inside. So it kind of makes sense. But I will give you, this isn't on here, but I'm going to tell you, if I were to put like a dot here and a dot here, those dots, they're also consecutive, but they would be called same side exterior, and they do have the same properties. It's just if they're both inside, they're interior. If they're both outside, they're exterior. I mean, you kind of know that just because you know inside and outside. But they are not equal, okay? They are supplementary. So that means this star 1, oops, let me change that color so you can see it. So star 1 plus star 2, these two are going to add up to 180. Dot 1 plus dot 2, they're going to add up to 180. So you've got part plus part equals 180. So the other three, they're all congruent. These two are supplementary. Okay, and let's make sure we don't forget we have linear pairs and vertical angles. Those still apply. Okay. All right, so let's do some just identifying over here. Okay, we're not doing anything but identifying. So which one of these lines is our transversal? Well, the transversal is always the one that goes through your parallel lines, so that would be line M. And your parallel lines are A and B. So lines A and B. So the cool thing with parallel lines and transversals is if you know one angle, like if you notice there are 8 angles here, which that's kind of a lot. But since this one's 120, then I know there are 3 other angles that are 120. 3 of them. The first one is angle 4. Angle 4 is vertical. All right, so I know that this angle is 120. This angle is 120, and this angle is 120 because they are vertical from each other. Okay. The next one that is also 120 is angle 5. So if I look at this angle right here is 120, I know angle 5 because remember this is our transversal. They're on the same side and they're both in that upper left-hand corner. So that means these two are corresponding. And please, you have to memorize these. Okay? You have to memorize these. All right, and then the last one is going to be angle 8, and it's alternate exterior. So I'm going back to this angle right here. If this angle is 120, then if I hop across and I stay on the outside, this one's also 120. So 4, 5, and 8 are all 120 degrees because they have a relationship with this angle right here. So I can have multiple relationships between angles. Now, please note, these 2 angles right here are supplementary because they form a linear pair. Okay, so I'm going to erase this so we can kind of look at this at a better view. So if this was 120, I know this one here is going to be 60 because these two have to add up to 180. If this one's 120, I know this one out here is 60 because they're same side exterior. Okay, 60 and 60, 60 and 60. So when you have parallel lines with a transversal, if you know one angle, then you know all of them because they're either going to be 120 or supplementary. There's only two choices. So let's see what that looks like. It says find the value of x and explain your reasoning. So first of all, I'm going to go through and I see that I have two parallel lines, transversal. So I know this angle right here and this angle right here are equal. This one is going to be equal to this one up here because these two are corresponding. And this one right here is equal because these two are alternate interior. So that means that since this angle is not equal, that means it's automatically supplementary. So I'm going to go x plus 5 plus 115, part plus part equals 180. That's one way, okay? Now, I also know if this is 115, if I take 180 and subtract 115, I get 65. So that means this angle is 65 because these two are supplementary, which means now these two, so x plus 5 is equal to 65. So you could either look at it one of two ways. If you know that these two have to add up to 180, then you can find this angle. And now you know that these two are going to be the same because they have the same tick mark. Or you could do this angle plus this angle equals 180. I think this way is easier because once I subtract 5, I get that x is 60. And I'm done. So explain your reasoning. You could put they are supplementary. So that is my reasoning. Okay. If you wanted to do it this way, then we would do x plus 120 equals 180 because 115 and 5 is 120. Subtract 120 and x is still 60. So either way. All right, find the value of x. Identify the relationship. So I noticed this is the transversal and they're both on the same side and they're outside. So these two are going to be same side exterior. So same side exterior angles are equal to 180. So my explain is their same side exterior and they are equal to 180. So I'm just going to take these two and add them together. 7x plus 9 plus 136 equals 180. So I'm going to add these two together. So 145 equals 180. So these two are like terms. I'm going to subtract the 145. So 7x equals 35. Then I'm going to divide both sides by 7. X is 5. All right. And the last one here, we're going to prove. All right, so the first thing I'm going to do is it tells me right here by these little arrows, that's my given. Okay, it tells me that P and Q are parallel. Now, I know that 1 and 3, because they want me to prove that, says prove that if two lines are cut by transversal, then pairs of alternate interior angles. So alternate interior, they want me to prove that 1 is congruent to 2. They want me to prove that. That's a squiggly. All right. So I'm going to start here. I know that angle 1 and angle 3 are equal to each other because they are on the same side. One's in, one's out. They're both in the lower left corner. So they're corresponding. Now I also know that 3 and 2 are congruent to each other because they're vertical. Okay, so 2 and 3 are vertical angles. So if I look at this, if 1 is equal to 3 and 3 is equal to 2, those two cancel, leaving me with 1 is equal to 2 by the transitive property. Okay? So You have to be able to identify the relationships. It is imperative that you know the location and the name of the location. Okay? So we will get lots of practice with this, all right? So that is the end, and they lived happily ever after, and I will see you guys later. Bye.